Hi guys, welcome back to my mathematics tutorial, and this lesson is the continuation of the previous lesson. Peter C. Dokpa Jr. is my name, and I am an instructor of mathematics at the University of Liberia. So in this lesson, we want to look at the question number 12, the 12th example, under finding derivatives of trigonometric function. So this is y equals to x raised to the power sine of x plus sine of x raised to the power cos of x. Now, like we told you in previous video, this is not like the way we had y equals. This is not like the power rule equals to x raised to n and y prime is equals to n x raised to the power n minus 1. No, this is not like the power rule. So we have to use natural logarithm to bring these exponents down, this power down. But in previous lesson, we had two terms, one on the left and one on the right. So we could easily take the ln on both sides. But for this case now, if we take the ln on this side and take the ln on this side, we cannot easily bring down these powers because the ln of x raised to the power sine of x plus sine of x raised to the power cos of x cannot lead us to a property of the ln that will bring these powers down. So what we need to do is that we need to consider this term to be a function, this term to be a function. So we need to incorporate two distinct functions. So we can call the first function, we just call the first function r. So we say let r equals to x raised to the power sine of x. Then we differentiate this r function. So the first thing we need to bring this sine of x down. So it's ln of r, take the ln of both sides, and ln of x sine of x. So you see, if you're doing this problem and this problem, you can represent this to be your r. You can also represent this to be your r. So we bring this power down. You have ln of r is equals to sine of x, ln of x. So the next thing is now to differentiate. So for this, we have 1 over r times the derivative of r according to the derivative of natural logarithm. For this case, now we have two separate functions being multiplied by each other, so we can use the product rule. So we hold sine of x and differentiate ln of x, we get 1 over x. If we differentiate this x, it just gives us 1. Plus, we hold this ln of x now and differentiate sine of x, we get cos of x. So since we hold this one constant, we just rewrite it. So what's next for us to simplify? Okay, this times r prime. So let's simplify now. So we have r prime. Now remember this r must be multiplied by this entire expression, like we cross multiplying. So this is r. Now we have sine of x all over x plus cos of x, the ln of x. So what do we know of r? R is equal to x raised to the power sine of x times sine of x over x plus cos of x, the ln of x. So this is the first one. This is the derivative of this one. Now we move to the second. We find the derivative of the second term. So we can say let that term be p. P is equals to sine of x raised to the power cos of x. So if you're solving these problems, also this will be your p. This will also be your p. So we take the ln on both sides. The ln of p is equal. Now we take the ln on this side as well. This cos will come down like it happens here. The sine of x came down. So this cos of x will come behind the ln. So we have cos of x, the ln of sine of x. The next thing we need to do is to differentiate. So we differentiate ln of p is just equals to 1 over p times the derivative of p, which is just p prime. Again, we have two functions here, so we use the product rule. We hold one of the function, cos of x, and we differentiate the next function. So this is 1 over sine of x, the derivative of natural logarithm is 1 over the function, times the derivative of that function, which is now cos of x. So we held this cos of x first and we differentiated ln of sine of x. So we can now say plus, let's hold cos of x now, let's hold ln of sine of x and differentiate cos of x. So the derivative of cos of x is just minus sine of x. So we rewrite ln of cos of x. So we can now simplify p prime. So p prime is equals, now we know that this p will be multiplied by this entire expression, which is p. So this is cos of x and cos of x, right? So this gives us cos square x all over sine of x. And then this is minus sine of x, the ln of sine of x. So what is p? Initially p was sine of x raised to the power cos of x. So p prime is, let's say p now is equal to, let's say p prime is equal to p, which is sine of x raised to the power cos of x, and then times this cos square x all over sine of x minus sine of x ln of sine of x. So now we can replace, we can put them in the original equation. So we can now find the derivative now of the original equation. Since we already know the derivative of these two terms, we can now find the derivative of the original function. So this, the derivative of y now is just y prime. So the derivative of this term, this first term, is just equal to this one, which of course we know that this is x. So we can multiply both of them, or we just leave it as it is. So it is x raised to the power sine of x times sine of x all over x, and then plus cos of x ln of x. So this is the first one, and then plus the next one is this. So this gives us sine of x raised to the power cos of x, and then times cos square x all over sine of x minus sine of x, the ln of sine of x. So at this point, you can decide how to write your final answer. It's not binding that you make your final answer to be a particular way, in a particular way. It's not really binding, so you can decide to rewrite it in any form you wish to rewrite it. So we can leave it as it is, or we can decide to just multiply this by this, this by this. It makes no difference to the problem. So we just conclude that this is our final answer. So this is how we find the derivatives of these kinds of functions. A function raised to another function. Sometimes it might raise to another function, it might raise to another function, as we will see in our other lessons. So you can practice these two problems, and if there's any concern, you can hit up in the comment section. Thanks all so much for watching. See you in our next class.